x to the third plus 27 is equal to 0. And if you want to solve for this, you have to factor this, and that is same thing as sum of two cubes. If you remember, sum of two cubes, a cubed plus b cubed. Okay, that factors to a plus b times a squared minus ab plus b squared. Of course, if you had difference of two cubes, a cubed minus b cubed, that factors to a minus b times a squared plus ab plus b squared. Okay, so this is same thing as 2x quantity cubed plus 3 cubed. Okay, and that's equal to 0. So we can factor this, and I want to factor that as a 2x plus 3. Okay, times, then the trinomial is going to be first term squared, which is 4x squared. Okay, and then if that's a plus, it'll be a minus here. And then multiply the first and second term, it's going to give me 6x. Okay, and then I have the last one's always plus, second term squared, which is 9, and that's equal to 0. This is prime. Okay, so you don't have to set that equal to 0. So you set this equal to 0, 2x plus 3 is equal to 0. Okay, and then when you solve, you're going to get 2x is equal to negative 3, and x is equal to negative 3 over 2. There it is. Alright, so there's one. This is actually 91/95. Okay, so let me do one more in terms of factoring, and let's see if we can factor that. So let's do, let me kind of go backwards here. Let me go backwards and do number 92. So x to the fourth minus 1 is really a difference of two squares, so I can factor that. I get x squared plus 1 and x squared minus 1. Okay, this is prime. Okay, so I can't factor that anymore. And this is x squared plus 1, but this can be split up as x minus 1 times x plus 1. Okay, and that is factored. Alright, so that's 91, 92, and 95. So let's go to the next problem I want to work out for you, which is number 98. Okay, that is x plus 1 over x minus x over x plus 1 is equal to 0. Of course, when you have fractions, you're going to have some solutions that will not work right before you start. You should know x cannot equal to 0. Okay, x cannot equal to negative 1. If we get one of those two solutions, we have to throw them out. That way I don't have to check. Okay, the next thing I want to do is I want to find the lowest common denominator, which is x times x plus 1. I need that to get rid of my fractions, so I'm going to multiply every term by that. So x times x plus 1, and then here it's going to be x times x plus 1, and here's x. Here I'm going to multiply by x times x plus 1. Okay, x's cancel out. What I have here is x plus 1 times x plus 1. Okay, minus x plus 1's cancel out. I get x times x, which is x squared. And then of course I'm still going to get a 0 on the other side. Okay, and I'm going to clean this up. I'm going to multiply all this together. So I'm going to get x squared plus 2x plus 1 minus x squared is equal to 0. Okay, x squared is going to cancel out. So I'm going to get 2x plus 1 is equal to 0. So I'm going to get x is equal to negative 1 over 2. And that's my solution. Okay. Let's go to long division. I'm sure you've probably forgotten how to do long division. Okay, we did this in Algebra 3-4. This is number 100. Okay, a quick review of long division. Okay, you have a x to the fifth minus x to the fourth plus x to the third plus 2x to the second minus x plus 4. And we want to divide that by, okay, x to the third plus 1. Okay, so we want to check and see if we have any missing terms. I have x to the fifth, fourth, third, second, and x to the first, and constant. That's good to go. But in this one, I have x to the third, but there's two terms missing, x to the second, x to the first. So I have to put zeros in place of that and then have a constant. So I'm going to take that outside. Okay. I'm going to write x to the third. I'm going to put a 0 for x squared, 0 for x to the first, and then have plus 1. On the inside, I have x to the fifth minus x to the fourth plus x to the third plus 2x to the second minus x plus 4. Okay, now I'm going to long divide. Alright, here's the long division. The first term is always going to be the same, x to the fifth. They always match up. Then you got to look at this term and say, what do I have to multiply this by to make it look like that? So I have to multiply by x to the second. So I'm going to finish multiplying x to the second by everything here. Okay? So when I do that, I'm going to get a plus 0, and then I'm going to have a plus x to the second. X to the second. Alright. So I am going to put some parentheses. I'm going to subtract. So when I subtract, the first terms cancel out. So when I subtract the second terms, I'm going to get negative x to the fourth. I'm basically adding. When I add these two, I'm going to get plus x to the third. And when I add these two, now remember this negative will make that into a negative, so I'm going to end up getting a plus x to the second. And then bring down the next term, that's minus x. So I need to copy down the first term as is, because that's what I need right there. So I got to look at this one and see what do I need to multiply to make it look like that. Obviously I need a negative, and I have an x. So I'm going to finish multiplying everything. Okay, so when I finish multiplying, I'm going to get a plus 0 minus x. I'm going to draw the line, put some parentheses, and I'm going to subtract. Well, everything in the bottom changes sign, so when I add those, they're going to cancel out. When I add the next column, I'm going to get x to the third. When I add next column, I'll get plus x to the second. This now is opposite because of this negative sign, so they cancel out. I'm going to get a 0. I'm going to bring down my next term, which is plus 4. Okay, copy down my first term again, x to the third. I have to ask myself, what do I need to multiply this by? Okay, I just need plus 1. So I'm going to put plus 1. When I'm finished multiplying everything by 1, then I'm going to get plus x to the third. I already have that. So 1 times 0 is 0, and 1 times 0 is 0, and 1 times 1 is 1. Then I'm going to subtract. Okay, the first terms cancel out. Okay, when I add the next term, I'm going to get x to the second. When I add those, I'm just going to get 0. And of course, this now becomes minus because of that minus. So I'm going to get plus 3. Okay, so when I divide that, my remainder, okay, is going to be x squared plus 3. So my remainder is x squared plus 3. And there it is. Alright. So in 102, this is P over Q's. I'm sure you've done the P over Q's also. So let me refresh your memory again. I have a 12x to the third plus 8x to the second minus x minus 1 is equal to 0. And then they're telling me all my solutions are between plus or minus 1, which means that my x is greater than or equal to negative 1 and less than or equal to 1. Alright, so what are my solutions to start with? What do I use? Well, first of all, I got to find factors of that number, which I call p's, which is plus or minus 1. Then I'm going to find factors of 12, which I call q's, which is plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and then plus or minus 12. Of course, my P over Q's, when I write P over Q's, I'm going to get plus or minus 1. Then I'm going to get plus or minus 1/2. I'm putting each one of these underneath 1. So I'm going to get plus or minus 1/3, plus or minus 1/3. Then we'll have plus or minus 1/4, I'm going to have plus or minus 1/6. I'm going to have plus or minus 1/12. Alright, so they're telling me my solutions is going to be somewhere here and here. So I'm going to try one of these. Okay, so your guess is good as mine, so I'm going to try -1/2. I'm going to use synthetic division, so I'm going to put -1/2 over there. Okay, I'm going to have a 12 and an 8, -1 and -1. Okay, if it works, I should get 0 right there. Okay, synthetic division. Right, we're going to add the first column, which is 12, then we're going to multiply by -1/2, which is -6, add the next column, okay, which is going to give me 2. Then we're going to multiply again by -1/2, which is going to give me -1, add, I'm going to get -2. When I multiply again with -2 times -1/2, it's going to be +1, and it turns out to be 0. Okay, we're trying to find all the solutions, so we found one. We found x is equal to -1/2 is 1. So what's left is, they start out with x to the third power, so what I have now is 12x to the second power plus 2x minus 2 is equal to 0. That's what I have left. But this is a quadratic, so it's not that hard. We're going to, first of all, reduce, divide everything by 2. So I'm going to get 6x to the second, okay, plus x minus 1 is equal to 0. Now I'm trying to factor if it's all possible. If I can't factor, then I can use a quadratic formula. So I'm looking for factors of 6 times 1, which is 6. So let's see if we can factor that and cross our fingers. Well, I need to make a 1 in the middle, so I might want to go 3 and 2, so 3x and 2x. Okay, I need to make +1, so let me put +1 here and a -1 there. So when I multiply 2 inside, I'm going to get -2x. When I multiply 2 outside, I'm going to get +3x. Okay, that's going to give me +x in the middle, so I'm good over there. Okay, so it looks like it's working. So -1 times +1 is -1. That takes care of my end number also. So alright, so we're in good shape. So we're going to set each factor equal to 0 and solve for x. So when I set my first factor equal to 0, 3x minus 1 is equal to 0, I'm going to get x is equal to 1 over 3. Okay, and then I'm going to set 2x plus 1 is equal to 0, and I get x is equal to -1 over 2. Alright, so I want to do one more example, and then we're done. So I want to go to problem number 104, and this is solving inequalities. I have a 2x minus 1, all that over 3x minus 2 is less than or equal to 1. Alright, I like to have a 0 on this side. I can't solve it. I can't cross multiply because I do not know if what I have on the left side is positive or negative. So I'm just going to subtract everything. So I'm going to have a 2x minus 1, all that over 3x minus 2 minus 1 is less than or equal to 0. Alright, I got to find the lowest common denominator, my LCD. LCD is 3x minus 2. So I can write 1 as 3x minus 2 over 3x minus 2. So this is 2x minus 1, all that over 3x minus 2, and that's minus 3x minus 2 over 3x minus 2, because that's the same thing as 1, less than or equal to 0. Okay, pen don't fail me now. Alright, less than or equal to 0. Alright, since they have same denominators, I can write this as a 2x minus 1 minus 3x plus 2. Remember the minus in the front of 3x minus 2. Okay, this right there will change everything in here to opposite where it is. So that's why you're going to get a plus 2. Is less than or equal to 0. And in the bottom, obviously, I have a 3x minus 2. So if I clean this up, I'm going to end up having a negative x plus 1, all that over 3x minus 2. It looks like we've done this problem before. Okay, so I have my two critical numbers. One comes from the bottom. When I set that equal to 0, 3x minus 2 is equal to 0. I get x is equal to 2/3. And the other critical number comes from the top. When I set negative x plus 1 is equal to 0, I get x is equal to positive 1. So I have two critical numbers. Okay? Positive 1 and 2/3. Number line analysis. So I'm going to have a 0 here. Call that 2/3. Call that positive 1. Partition on 1. Partition on 2/3. Alright, pick any number, but we have test every single interval, so might as well pick 0 on the left hand side. Putting 0 here on the top, I'm going to get, for the x, I'm going to get a positive. When I put 0 there in the bottom, I'll get negative. So positive or negative is negative. Then we'll pick a number between 2/3 and 1. So how about 0.9? Okay, if I put 0.9 in place on the top right there, okay, that's negative 0.9 plus 1, top is positive. If I put 0.9, okay, there, 0.9 times 3 is almost 3, so it'll be bigger than 2, so it's going to be positive also. So positive or positive is positive. And then all the way when I go to the right side and I put a billion, top is negative because negative sign right there, and then bottom is positive, okay, so it becomes negative. Okay, so on the far side it's going to be negative. We're looking to see where it's negative, less than or equal to 0. It's less than or equal to 0 there. It's less than or equal to 0 there. You can write this as x is less than or equal to 2/3. Okay, and x is greater than or equal to 1. Okay. Alright, so if you were to write this in interval notation, it will look like this. Okay, I have a negative infinity to 2/3 with the bracket because of the equal sign, and then I have a union, and then I have a bracket on 1 because of the equal sign. Okay, there it is, and then comma to positive infinity. Okay, that's it. You can either write it like that, or you can write it like this. Either way is fine. Okay, that's everything. So